Good morning and welcome to my presentation. I am Jagdut Mashana, PhD student CSBET, supervised by Professor Dr. Mohammad Saburaman sir and co-supervised by Professor Dr. M. Solomon sir. Before starting my presentation, I would like to offer special thanks to the chairman and all the members of the board of examiners. The title of my presentation is the effective use of data method for machine learning applications. This is the outline of my presentation. First is motivation. Data is everywhere. Everyone is generating data. We have telecom industry data, health sector data, loan industry data, and many more. We use this data to train a machine learning model, but not need to people fitting into the machine learning model. There are several steps in data processing like data cleaning, machine learning, linked Boolean coding, data transformation, etc. These research mainly focus on the data transformation method. There are several data transformation methods like log, Bosco, rank, ZScore, root evidence, etc. But the problem is not all the transformation methods are suitable for the same machine learning application. In this research, we have investigated the effectiveness of data transformation method in various machine learning applications. The application of the data transformation method is it improves the prediction performance and it is applicable for the database in the machine learning model. Now, the research gap, a handful of research has been published focused on the data science method like telecom industry, telecommunication industry, e-commerce, etc. But those studies failed to find out the most suitable combination of machine learning model and data science method for a particular domain. To the best of knowledge, the effect of data science method has not been well studied in many fields like data privacy, healthcare, learning sector, etc. The aim of the research is to investigate whether and how data science method may affect the machine learning performance. To explore the data science method in the context of data privacy, to investigate how data science method affects machine learning explainability, to improve the application performance and the kind of all the application domain that we explored. This is the objective and outcome of this research. The objective of the research is to develop a customer prediction model using the data stream method, develop a adaptive data stream method, to develop a data stream based learning prediction model, to incorporate data privacy in the customer prediction model, to develop data stream based distributed parent-symmetric combination framework, and to incorporate explainability technique for the proposed model. The outcome of the research is a better understanding of effectiveness, activity, or suitability of data stream method, a list of machine learning model with high efficacy using the current data stream method for the customer prediction in the telecommunication industry, a list of data stream based machine learning model with high efficacy for the loan eligibility prediction, and a novel framework for people-specific customer model in the telecom industry, exploiting the power of data stream method. Enable data based parent-simple computation in distributed settings, and a better understanding of online decision-making process of the machine learning model. This is the mapping among the objective aim and outcomes of this research. At first, we developed customer prediction model in the telecommunication industry, where we investigated the effectiveness of several data stream methods. In the telecom industry, customer problem is one of the major issue, and we can train a machine learning model to identify the customers who are likely to son. The main research gap here is that the impact of data stream method has not been investigated deeply. The objective of this learning prediction customer prediction model is prediction problem is examining the effectiveness of various data stream method for the customer prediction and improve the prediction performance. This is the block diagram of our proposed customer prediction model. After some preprocessing, we applied several data stream method. Then we perform phase section and hyperparameter tuning. And finally, we change the model and evaluate the model using full evaluation matrices. The experiment has been conducted on full probability of data sets. This is the performance comparison for the raw and other data based model. in terms of 4 regression matrices for 8 different classifiers using the dataset on. From this heat map comparison, you observe that across the all regression matrices, most of the cases evidence shows the high prediction performance than the other methods, except for the recall. In the recall, we observe that raw-based FNN shows the highest prediction performance. But if we observe in the precision, we observe that the raw-based FNN show very poor performance. That means the raw-based method failed to train the FNN model. On the other hand, whatever evidence model or whatever evidence based model constantly shows better prediction performance than its counterparts. We also found almost similar prediction pattern for the other two data set. Then we perform statistical sigmoid test, and the Friedman statistical test ranking shows that whatever evidence based method based model shows the highest rank, and it also the Friedman test also reaches the null hypothesis. Then we perform a post-hoc analysis and the parallel post-hoc conversion. For the parallel conversion, the post-hoc analysis rejects the null hypothesis. That means that means the weight of evidence methods show outperform the other methods. We also compare our proposed method with the previous extra methods, and we found that weight of our proposed weight of evidence based FNN and the rest shows the high prediction performance than the previous methods in terms of accuracy and measure. So from the previous comparison, statistical tests and discussion, it is clear that data method improve the prediction performance and which is statistically significant. After demonstrating the power of data method in the telecom industry, we focus our research on developing a new data method which will improve our prediction performance and preserve data accuracy. We observed that though whatever evidence very effective and improve the prediction performance, it has some limitation. The limitation of the combination of weight of evidence are with the appropriate bean size, the prediction performance can be improved. When the distribution of positive event or negative event is 0, it replaces the corresponding weight of evidence value is 0. For continuous, we will know fixed rule for binning. To overcome this problem, we propose a lone adaptive weight of evidence data method, which is developed based on the conventional weight of evidence. It is a binning and logarithm based transformation, and the number of bin changes dynamically based on the characteristics of the data set. It improves the prediction performance of the data set. This is the flow chart of the combination of weight of evidence and adaptive weight of evidence. In the combination of weight of evidence, at first it says the number of bin equal to the number of meaningful of the features. Then it divides the underlying sample into the bin. Then it calculates the distribution of the positive and negative bin for each bin. If the positive or negative distribution of each bin is 0, it says the corresponding weight of evidence value is 0. Otherwise, it calculates the weight of evidence value with this equation. And finally, it replaces the bin values with this corresponding weight of evidence value. In the adaptive weight of evidence method, at first is calculate the number of meaningful of the feature. With the number of meaningful of the feature greater than lambda, it says the number of meaningful to the number of sample divided by q. Otherwise, it says the number of bin equal to the number of meaningful of the features. Then it divides the underlying sample into the bin. Then calculate the distribution of the positive or negative bin for each bin. Then calculate the output value with this equation. Here we add epsilon value, both is numerator and denominator. And finally replace the bin value with this corresponding value. This is the block diagram of our data synthesis method. Here we use only two data transfer method. One is the conventional weight of evidence and another is the adaptive weight of evidence. And we train 7 different machine learning classifiers. Finally, we evaluate the model using 6 regression matrices. The experiment has been conducted on 3 different data sets from 3 different domains. At first, we determine the key value, optimum key value of the adaptive weight of evidence. To find the optimum key value, we perform several experiments. And this is the performance distribution of the classifiers for the defined key value in terms of accuracy and depth measure for the data set 1. And from this box plot diagram, we observe that when the key value is 10, we achieve the highest performance distribution in terms of accuracy and depth measure. And for the data set 2, we also achieve the high prediction distribution for the key value is 10. And but for the data set 3, we achieve the highest performance distribution for the key value 20. So for the data set 1 and 2, we set the key value equal to 10, and for the data set 3, we set the key value equal to 20. So this is the performance comparison between the adaptive weight of evidence and conventional weight of evidence in terms of 6 regression matrices for the 7 dependent classifiers. And for the using the data set 1, and from this comparison, we observe that adaptive weight of evidence shows the higher potential performance across the all evaluation matrices. We also found almost similar prediction result for the other two data set. Then we perform statistical sigmoid test and the Wilkinson scientist using null hypothesis in terms of accuracy, method, and AUC. So it is from the previous comparison and statistical test, it is clear that whatever been outperformed the conventional weight of evidence. Now the role of adaptive weight of evidence on data distribution. This is the SQ and cartridge value for the first 10 features of the data set 1 in terms of raw weight of evidence and adaptive weight of evidence. And from this table, we observe that both that adaptive weight of evidence based method shows less SQ and less cartridge value, which is the sign of the improvement of the data distribution to the normal distribution, and which helps to improve the prediction performance. Another role of adaptive weight of evidence in modern experimentation. This is the sub result for the data set 1, which is the sun prediction problem. And from the sub-analysis of the raw-based method, we observe that total minute use, total observation minute use are the most important features. On the other hand, in the adaptive weight of evidence method, the sun is influenced by the wide range of features rather than limited by a few, which makes the model more powerful. Another key observation is that in the adaptive weight of evidence model, consider both collectivities and revenue matrices to identify the semantics. Adaptive weighting also work as a data privacy, which work as a work like a k-anonymity, particularly it is examination-based k-anonymity. In the k-anonymity, multiple record replaced with a single record. Like in this example, all 4 records replaced with a single record, and the all 4 values replaced with a single value, which is 47 to 59. On the other hand, in the adaptive weight of evidence method, all 4 edge value replaced with a single weight of evidence value. Suppose in a unified distributed data set, K is the minimum sample size of a bin, and Qi is the set of Gaussian identifier for individual records, where Q1, Q2 are the features. When we apply the adaptive weight of evidence on the Gaussian identifier, we get the transfer data set DW, where at least K records the same Gaussian identifier value. Like in the example where if the K value is 4, it shares the 4 record with the same Gaussian identifier value of a transfer data set, which is the adaptive weight of evidence value. So the probability of de-identification is at most 1 by K. This can be represented with this equation where the Y is the member of transfer data set and Gaussian identifier Y equal to the transfer data set of Gaussian identifier X, which is less than or equal to 1 by K. So the previous conversion statistical test and the privacy analysis, it is clear that weight of evidence is repetitive if the British properties and preserve the data privacy. To find the to see the potential of our proposed adaptive provider evidence, we pick the loan liability protection problem, and where we examine the effectiveness of adaptive provider evidence and other adoption methods. The research gap in the loan eligibility protection is several another research gap in the loan eligibility protection. Several machine learning and data mining technique has been used to tackle the loan eligibility protection, but the performance is still not satisfactory. US did not consider the privacy issue, and they utilize only one data set to the best of knowledge. The impact of on data set has not been investigated thoroughly. And the objective of the loan interpretation research is to close the research gap, examine the effectiveness of adaptive evidence and other data science method, explore the role of adaptive evidence in the model explainability. It improves the prediction properties and is of the database. And the contribution of our contribution for the loan eligibility prediction, we use different data science method, 11 machine learning classifiers. We performed correlation analysis, stress selection, other tuning. We conducted our research on 7 public available databases. We evaluated our model using CC evaluation matrices. We performed sub-analysis, statistical significant test, compared with STABART methods. It improved the prediction of the database. In the block diagram of loan prediction problem, we performed several data processing steps, and then we applied the several data stream method, including our proposed adaptive provider evidence data stream method. Then we perform pre-selection and perform training, and then we train the model, and finally we evaluate our model using CC evaluation matrices. We conducted our research on 7 publicly available data set. This is the performance comparison among the model in terms of F measure for the raw and other data simple method across the 11 different machine learning classifiers for the 7 different data sets. And from this heat map comparison, you observe that adaptive evidence-based model shows the higher prediction performance than the other methods. Another key observation here is that for the dataset 3 and dataset 4, we achieve most of the cases we achieve highest 100% prediction performance. We also observe almost similar prediction result in terms of other evaluation matrices across the wall 7 different datasets. And then we perform a statistical significant test, and the Friedman statistical test shows that the adaptive based method achieved the highest rank, which also reject the null hypothesis because the p-value is very less than 0.05. Then we perform the post-hoc analysis, and the home post-hoc analysis shows that the parallel comparison reduces the null hypothesis. That means the adaptive evidence outperform the other methods. Then we also perform the SAP analysis of our model, and the SAP analysis of the Robbins method or Robbins model shows that revolving utility installment and figure are the most important features. On the other hand, adaptive evidence method shows that revolving balance debit income ratio and instruments are the most important features. The revolving balance and debit to income ratio are the well-established metrics in the lending industry, and they are highly correlated with the borrower repayable capability. So by enhancing those pieces, the adaptive evidence improve the prediction performance. Our proposed methodology also preserve the accuracy because we apply adaptive evidence on the dataset before feeding it to the machine learning model. As we discussed before, since adaptive whatever evidence immediately preserve the database, our proposed model also, our proposed loan eligibility prediction model also preserve the database. We also compare our proposed model with the previous state-of-art methods, and we found that adaptive algorithm robust and adaptive algorithm then ensure the high prediction performance in terms of accuracy and measure. Another key observation here is that previous did not consider the data privacy issue, and our proposed model also pick up the data privacy. To the previous comparison, discussion, statistical significance, privacy analysis, it is proved that our proposed loan interpretation model, interpretation pattern, includes data privacy, which is tested on seven properly applicable data sets. Uh, we another focus of our research is data privacy, and we develop a privacy prediction model for the telecom industry, leveraging direct proprietary evidence in conjunction with the GAN. In the telecommunication, now the problem of the telecom industry is now the privacy in the telecom industry. The robot that we use to train the machine learning model may contain private sensitive information. But the telecom industry usually use third-party cloud computation to train the model. But training a third-party cloud computation, but training a model using third-party cloud computation has several issues like training model using raw data is a privacy threat. Privacy can be breached due to the disconnection period service provider. Data can also be leaked due to the can be leaked unintentionally. Training model also suffer privacy data. Now the research gap for the privacy preserving customers and prediction problem. Several techniques have been used before uploading data on the cloud server, like the public traffic encryption, who encryption, pilot, fully encryption, obfuscation, deobfuscation, differential privacy, etc. But the problem is all these methods negatively affect the machine learning performance. And the objective of this privacy preserving customer problem is objective is to close the research gap and propose a privacy preserving framework, and which will potentially outperform the rest and others. Another contribution for the privacy preserving customer protection problem, it is the GAN and adaptive evidence-based framework. GAN is used for defense privacy, and adaptive evidence at another privacy layer, which also into the protection performance. We use 8 different machine learning classifiers, and we conducted our research on replicable dataset. We evaluated our model using 6 evaluation matrices. We performed a statistical significance privacy analysis compared with the estimate methods. It enhances the prediction performance of the data privacy. To the best of our knowledge, this is the first study of privacy preserving customers and prediction model in the telecommunication industry. This is the block diagram of our proposed privacy preserving customers and prediction framework. After sample processing, we divide the dataset into 10 and test set. Using the 10 set, we train a GAN model and GAN index noises in the dataset. And from the 10 GAN, we generate synthetic data. Then we perform adaptive evidence model on the synthetic data and uploaded the data on the cloud server. After the data method has been performed on the cloud side, this is the phase 1, and the phase 2 is performed on the cloud side. After the model training, we evaluate a model in the client side using the 6 evaluation matrices. Before perform testing, we perform testing with the original data set. Before perform testing, we applied the required evidence on the original test data. As we generate synthetic data from the GAN to see whether the different synthetic data provide different prediction performance, we generate 10 different synthetic data from the GAN model corresponding to the original data set on. And we perform testing, and this is the performance distribution of the 10 different synthetic data corresponding to the original data set on in terms of 6 several matrices for the naive-Bayes and the registration. From this box plot diagram, we observe that in terms of accuracy, F measure and AUC, each shows the performance distribution is almost same. But for the specificity precision recall, we observe that the box plot diagram is relatively bigger. But if you consider in terms of number, the difference is very low. It also observed from the naive-Bayes and the lowest regression. That means the difference in the data provide almost similar prediction performance. And now this is the performance comparison for the 4 different methods, which is raw, GAN, adaptive evidence, and GAN adaptive evidence using the dataset on. for the 8 different classifiers. And from this comparison, we observe that across the all liberation matrices and classifiers, adaptive weighted evidence shows the highest prediction performance, except for the knife base. For the knife base, we observe that GAN adaptive weighted evidence shows the high prediction performance. Sometimes we observe that the recall is very high for the GAN-based method, but if we consider the specificity, we show that it is very poor. That means the GAN-based model failed to train the GAN-based method failed to train the model. We also observed almost similar prediction result for the other two data set. Then we perform the statistical significance test, and here we compare between the raw and GAN adaptive weighted method, and the weighted percentage is the null hypothesis, and in terms of accuracy and F measure. So from this previous comparison and statistical test, it is clear that GAN adaptive weighted evidence outperform the raw-based methods. Now the privacy analysis, the analysis of our privacy preserving framework. Here we use DPU GAN, which is the differential privacy version of a GAN, which is generate our synthetic data. In this DPU GAN, we have a parameter called epsilon, which control the differential privacy or data privacy. When the epsilon value is low, it injects the higher noise, and when the epsilon value is high, it injects the lower noise. In our experiment, we found that when the epsilon value is low, the GAN adaptive weighted method shows the lower accuracy, and when the epsilon value is higher, we achieve the higher accuracy. As per the previous study, as per the suggestion of the previous study and the privacy preserving rule, data privacy preserving rule, we said that epsilon value is 10, which will provide the dimensional privacy. We use the DPU GAN, which provides the dimensional privacy if we set the Q value is 10 or equal to less than 10, and we set the Q value is 10, and which provides us the dimensional privacy. And we also applied the adaptive weighted evidence on the data set before applying on the data set, as we discussed before. Adaptive weighted evidence to the data privacy, and in this case, adaptive weighted we append the adaptive weighted evidence. We also add another privacy layer on the data set, which ultimately preserve the preserve of the training model as well. This is the impact of GAN and adaptive weighted evidence on the data distribution. This is the skip value of the first and future of the data set on for the GAN and adaptive weighted method, and we observe that GAN adaptive weighted evidence provide us the less skip value. So from this comparison, it is we can say that GAN inject the noise in the data set, but adaptive weighted evidence reduce the influence of the noises, which help to improve the validation performance. We also compare our proposed model with the previous standard method, method. And from this comparison, we observe that GAN adaptive based knife base and registration show the high prediction performance than the previous study in terms of elevation matrices. And our fourth model also with the better privacy, and the previous study did not consider the privacy issue. So from this previous comparison, privacy analysis, statistical test, it is clear that our privacy framework is of data privacy for the customer prediction problem. It improves the validation performance as well, and which is tested on a 3 public data set. To see the effectiveness of our proposed adaptive weighted evidence data system method, we use this for the presence-simulated competition, and the title of the research is presence-simulated competition for the clinical training support and effective use of data transmission combining the static and time series data. Now the research gap, several participatory technique has been used to tackle the but the performance is not satisfactory. Dynamic typing method, which is very suitable, which is very popular and suitable for the time series similarity, but this is usually do not use this method due to the highest competition issue. To the best of knowledge, there is no study, this is study on congestive heart failure for the prevention ready. As far as you know, they picked up the ultrasound method in the prevention ready competition has not been investigated deeply. The objective of this prevention competition is to close the research gap, improve the prediction performance, research the accuracy, and potentially fulfill the real-time competition demand. Now, the contribution for the prevention competition. We used both timesheets and strict data. We used two data stream methods for clustering algorithm. We performed dynamic time mapping for the timesheets similarity. We use distributed SQL computation. We tested our framework for the two different problems. One is the coronary artery disease, another is the congestive heart failure. We evaluate a model using simulation matrices. We perform statistical significant tests, sub-analysis, and compared with the previous standard models and building models. It improves the prediction performance after the database. With the best of knowledge, this is the first implementation of distributed SPAC and DW-based time series similarity competition in conjunction with data stream-based clustering technique for the application similarity prediction. This is the this is our proposed distributed preference similarity framework. At first, we applied the data stream method on the study data, and we performed the clustering technique in the cloud environment, in the cluster in the SPARC environment. When we get a targeted patient, first we determine the cluster of the patient, and based on the cluster, we calculate the similarity matrix using the time series data based on the DW computation. As we have n number of time series items, we get n number of similarity matrix. From the each similarity matrix, we get at least one nearest neighborhood patient. Together with the all nearest neighborhood patient, we generate a nearest neighborhood fusion. For the nearest neighborhood fusion, we get our prediction based on the voting method. This is the experiment result for the two different data stream method and for clustering algorithm. In terms of 6 evaluation matrices for the coronary artery disease and congestive heart failure. For the coronary artery disease, we observe that GAN adaptive variant based chemistry shows the high prediction performance in terms of all evaluation matrices except for the specificity. For the specificity, we observe that GAN adaptive variant based optics show the high prediction performance. In terms of congestive heart failure, we observe that GAN adaptive variant based chemistry shows the high prediction performance in terms of all evaluation matrices except for the specificity. For the specificity, we observe that adaptive variant based optics shows the high prediction adaptive variant optics and expect shows the high prediction performance. We use DTW computation for the time series similarity. This is very effective, but it has huge computational cost. To reduce the computational cost, we use the distributed SPAC computation, and this is the performance comparison between the execution time and the number of patients. Where we fix the time series data length, which is 60, and we send the number of patients. And from this comparison, we observe that SPAC-based DTW computation requires less time than the conventional weighted evidence. Even we increase the number of patients, it requires less time with respect to the conventional conventional DTW computation. When the number of patients is 100, it requires only 53 seconds for 53 seconds. That means for a single patient, it will meet the demand times computation demand, even it increase the data size. We also perform the statistical inventories further to identify whether our proposed performance of the proposed method perform better, which is a random or not, which is significant or not. And from the fitment ranking, we observe the adaptive vitamin based preference computation shows the highest rank. And then we also perform the posterior analysis, which also reveals the null hypothesis. That means the adaptive vitamin based preference computation outperform the other methods. We also compare our proposed method with the state of our time and several baseline method. We build several baseline method with as per the because that prediction problem that you work on not available in the literature. So we build several baseline method based on the suggestion of a previous study, and we compare with our proposed model, and we found that in terms of accuracy, net measure and AUC, our proposed model shows the hybrid performance both for the boundary averages and chemistry heart failure. We also perform the SAP analysis of the proposed model, and the SAP analysis of the Robbins method shows that the patient developing improvement, which is the age, weight, height, are the most important features. On the other hand, the adaptive evidence shows that the patient medical record shows the highest, most important features like the admission type, conduction heart failure, like this. It is also observed for the both congestive heart failure and coronary artery disease prediction. And it is well known that the patient background record and the the medical record record shows the current status of the patient health record, patient health current status of the patient health status, and so by emphasizing those features, whatever it is improve the prediction performance. Our proposed model also of future data PVC, system data that we use in this result, we use dictionary data, which is a combination of patient demographic information and background record. Those data are sensitive in terms of legal and ethical context, and budget user target those data. We applied the adaptive evidence method on the static data before fitting into the training process. As we discussed before, adaptive evidence preserve the WBC, it immediately preserve WBC of our proposed presence and distributed propensity computation method. So from the previous analysis, combustion calcium point test, and execution time comparison, and privacy analysis, we can say that the proposed method improve the prediction of parents and pick up data privacy and meet the real-time computation demand. Which is, and we tested our proposed framework on the two prediction problems. This is congestive and coronary artery disease. And the feature of predicting customer behavior is challenging and continuous process. We can use the clustering technique or seasonal trend to predict the customer behavior. The effect of whatever evidence need to test on the other domain like the e-commerce, travels, weather, etc. To enhance the prediction performance, the privacy of the loan prediction, we can use the GAN attributed method. Affiliated learning can also be used for the patient similarity computation. GAN attributed technique can be used, and this approach, our proposed patient similarity approach, can be used in the cross-domain similarity. Now the concluding remark. At first, we developed customer simulation model where we examined the effectiveness of several data methods, and we found that weighted evidence is the most effective one. Then also we found that found some limitation of the weighted evidence method, and we updated the weighted evidence method and called the adaptive weighted evidence association method, and we explored its applicability in several application domains. It improved the prediction performance of the WC. Then, by leveraging the adaptive evidence, we develop a low energy prediction model, which improved the prediction performance of the WC. And after then, we propose the privacy preserving framework, leveraging the adaptive evidence in conjunction with the GAN and differential privacy. Finally, we propose a distributed financial computation, leveraging the proposed adaptive evidence in conjunction with the time series and stored data. This is the references. Thank you.